a little bit past 2. We'll start things off, assuming, some other people will be jumping in. But welcome everybody to our first webinar for our Making Waves webinar series by the Coastal Program. We're really excited to be kicking this off for 2026. It was really, our staff meets pretty regularly, and we're like, oh, wow, we have so much data and resources coming out. It'd be great if we could have a platform to share these. So we're really excited to be producing this webinar series. It will be recorded. I believe this one's already being recorded. We'll be posting it online for folks to view afterwards, but it's really to serve as a way to share resources with folks. The slides will change. So what is this webinar series? We're hoping it will be a bi-monthly webinar series, again, to share recent or ongoing projects by the Coastal Program or our partners, focusing or emphasizing, projects, resources, new data, just really exciting stuff we want to share with the community. And so that is the goal, is, really connecting these resources to the communities, practitioners, and partners who may find it interesting or useful for their line of work. Specifically, we're targeting key topics such as, coastal restoration, protection, coastal hazard planning, and climate adaptation strategies. And today's theme is all focused on the new Coastal Viewer. Right there. So we have a series of talks really highlighting, new resources on the Coastal Viewer, as well as just navigating the Coastal Viewer, as well as some data that is to come. So, we'll have a couple of talks here. Each are about 10, 15-ish minutes, probably closer to 10. And then at the end, we'll have a Q&A session. So folks, feel free to either stick your questions throughout the webinar, either in the chat or the Q&A section, or just hold on to it till we get to closer to, say, 2:40, 2:45-ish. And then we can have an open discussion. Then with the last few minutes, we're just going to wrap up, let folks know when our next webinar is going to be. But yeah, I think at that point, we'll hand it over to our first speaker, who is Rebecca Bannon. She'll be providing an introduction to the Coastal Viewer. Rebecca, if you want to introduce yourself, I will run the slides for you.
Great, thanks. So yeah, I'm Rebecca Bannon, and I'm project director at New Hampshire Granite, and I'm really excited to get to help kick off this webinar series and talk about the Coastal Viewer. Many of you are probably familiar with the viewer. You might use it quite frequently. My goal today is to briefly introduce the viewer and demonstrate some of its key features. And along the way, I'll point out some of the things that have changed over the last year. So you can next to figure out how to advance slides here. So the Coastal Viewer is an online mapping tool that offers users access to spatial data related to New Hampshire's coastal resources and hazards. It was developed and is being maintained by Granite in partnership with the DES Coastal Program. The original development was funded by NOAA's Office for Coastal Management, and subsequent support has been provided by NOAA and the Coastal Program. Almost a year ago, the viewer was updated into Esri's Experience Builder platform, and it's integrated with ArcGIS Online. So now we can look at the basic layout of the page. Next. It's really not changed much since the Coastal Viewer was first put together. The main feature is the map, and then along the top is a toolbar and a search box, and down the left side is an information panel. We maintain a running list of things that are updated with the viewer and its data so that you can quickly see when something might have changed. Next. So to start working with data, you can click Layers List at the top of the information panel. the data is organized in a folder structure, and to turn on a data layer, you click the caret or the arrow next to a category and check the box. So next slide. So to turn on conservation and public lands, we would expand the heading conservation, environment and conservation, and check that box. And next do that with conservation and public lands. And then under that, you see 5 layers. And those are all different ways of symbolizing the parcels in the conservation and public lands. So you see that primary protection type is turned on, that box is checked, and so that's what's displayed in the map. If you click the icon next to the layer name, you can see the legend for that layer, and so then you can see all the symbols that are used in the map. Okay, next. Sometimes a data layer might cover up another layer. So in this case, the conservation and public lands are obscuring the river that's flowing underneath. So if you click the options menu next to a layer name, it looks like 3 dots. You have some choices, and one of those is transparency. So if you click transparency, you'll get a slider, and you can adjust that transparency of that layer, so now you can see the river showing through the conservation and public lands. Next, we could look at some more things that are available in that options menu. You can turn on and off labels. You could set a filter on a data set, but you can also get metadata. If you click on details, you'll get metadata for that document, or for that data, which is the documentation. So clicking that details has opened this item in ArcGIS Online, and you'll see there's links to more things. So there's the PDF of the conservation land standards for submitting conservation lands to Granite. Up in the right corner, you could open this layer in a new map viewer project, and then there's another view metadata button there, and if we click that, we get even more information about this layer, so you can see the full record, and this would include a link to the service for that data if you want to use that in another project, and also a link to Granite's FTP site to just download the whole thing. Okay, so now we can talk about navigation in the map. The quickest way to get to a place in the map is to use that search box up in the right corner. So if I type in an address, you could go to the next slide, and then click on the suggestion that it gives, it will place a point in the map and zoom to that location. Another navigation tool is down in the lower left corner. There's a coordinates button, and that lets you go back and forth between coordinates and addresses. You can also use that to click in the map and place points and get coordinates or addresses if you like. Next, in the map itself, there are zoom and extent buttons, and the little house icon will take you back to the original default extent of the map. There's also a base map selector that'll let you choose from a number of base maps to highlight the data that's of interest to you. This also provides a quick shortcut to the 6-inch orthophotography from 2021, but there's also a lot of imagery available in the layers list in the base maps and imagery section, going all the way back to 1962 is the oldest one we have there. So next I would talk about, sorry, one more thing in the layers list. When you are, no, you can go back, Aiden. When you're exploring data in the layers list, you might find some layers that are grayed out, and this means you need to zoom in to view these layers. So this is called scale dependency, and it keeps large complex data layers from slowing down the viewer at small map scales. So the 2-foot contours are an example of this. And then if you zoom in the map, you can go on, Aiden, then these layers are no longer grayed out and they draw in the map. All right, so next I would talk about the buttons in the toolbar along the top. The first one I wanted to talk about is themes. So themes allow you to look at a subset of data layers around a specific topic. This is really useful because a small number of layers is going to draw a lot faster than the whole list of data that's available. So when you click on the themes button, you'll see in the left information panel there are a number of them listed. There's coastal flooding, the Landowner Technical Assistance Program, salt marshes, stream crossings, Land Protection Transaction Grant, the Stewardship Grant Program, and the Coastal Watershed Conservation Plan. So if I click on the coastal flooding, then you'll see there's just a small number of layers that are available. To go back to the full list, you would just click, there's a all layers at the top of that list. That would take you back to the main map, or the home button that you can see in the left end of the toolbar there. Another tool that you might want to use is add data. This allows you to add additional layers to the map from something you might have on your computer, or ArcGIS Online, or a service. One place that this might be useful is if you are working in a theme and you think of another Coastal Viewer layer that you'd like to add, you can select Coastal Viewer layers in this menu here, and you could search for the data layer you want. And this menu would have all of the layers that are on the Coastal Viewer by default. A fairly new addition to the Coastal Viewer is an additional layers list. So if you go to the next slide, if you choose additional layers in that drop-down menu, you can get some things like additional years of eelgrass data, or additional years of NAPE imagery. These have just been moved out of the default list to streamline that list, but they are easy to find using this tool. So when you click Done, the bottom of that, then the layer that you've selected will appear, it'll be displayed there in that Add Data menu, and it'll also be in the layers list. Another tool that you could use is Draw and Measure. Measure lets you measure areas and distances. Draw allows you to put shapes, lines, polygons, and even text in your map. You can choose what kind of drawing or text you'd like to put in the map. You can customize what you'd like that to look like there in the information panel. And there's a button for turning on measurements if you'd like it to measure as you draw. You can also get a little fancier with your drawings. In the next slide, you'll see you can make your drawing match another layer in the map. So you do this by enabling snapping, and then that will bring up a little list of data layers that you could select what data set you'd like to snap to. And then as you add points in the map, when you have snapped to another layer, you'll see those orange indicate lines. So that would just let you, just match the dimensions, the lines of something else in the map. So once you've added drawings or text to a map, you might want to share it with somebody else. And you can do that using the share button, which will open this print widget. There are a few things you can customize in the print widget. And then when you click print, a link will appear in the results tab there. And you can click on that link to get the PDF of your map, and then use your browser buttons to download that if you want to keep it. There are also in this print panel, there are also buttons to get links to share the Coastal Viewer. You could, these would provide someone else an easy way to start working in the Coastal Viewer at the location and with the data layers that you have turned on. And so in the last slide, just a couple of notes. The viewer works best on a larger screen, but it does work on tablets and phones. There are a little handles in the middle of panels and toolbars that you could use to maximize space if you need to. And just I encourage you to explore on your own. With GIS, there are always a lot of ways to do any given thing. So explore and figure out how you like to do things. And we always welcome your feedback and your questions. So you can contact us at granite@unh.edu, and we look forward to hearing from you. Thanks.
Thank you, Rebecca. That was awesome. I feel like I hear a lot like folks wanting to see this type of tutorial going through the Coastal Viewer. So this is awesome. Really appreciate it. All right, and folks, just remember if you have questions or comments, just throw them into the Q&A or the chat, and we'll tackle them near the end of the hour. But we'll move on to our next talk, which is Jane. We'll be talking about the new groundwater rise map. So I'll hand it over to you, Jane.
Okay, thank you, Aidan. Becca, thanks so much. That was terrific. That was a great overview. And I learned a lot. So it'll be nice to have this as a recording to help people get the most out of the Coastal Viewer, which is really awesome. So I'm talking about the groundwater modeling work that we've done in the New Hampshire coastal area and mapping, and we put a lot of our results up on the Coastal Viewer. So this is kind of an introduction to what is there. This project is funded by New Hampshire DES. Next, please. Yeah, so this slide is just showing you the model domains. So the way we got this information is we did groundwater model, which is a USGS tool for simulating groundwater flow and groundwater levels. So it's actually 4 models. There's a Dover and Durham area model, which is shown in the light green, and then a Newfields Exeter, and then the New Hampshire seacoast to the south, and Portsmouth and Newcastle. And the reason I'm showing you these model domains is that the results that are being presented on the Coastal Viewer are really coastal results. We're looking at the effect of sea level rise on groundwater levels at the coast. But these models cover a large area. And so if modeling results are needed for other projects in the future, like water supply or groundwater quality, many different things. These are areas that have been modeled, and that information is available. So the groundwater model resolution, the Dover model, Dover Plus, is 400 feet by 400 feet. And by the resolution, that means that these are grid cell sizes. So when we have a groundwater elevation, it's really an average elevation over that square footage for 400 feet by 400 feet in that area. Newfields and Exeter, near the coast, it's 100 feet by 100 feet, and more inland, it's 400 feet by 400 feet. Portsmouth, same thing. The seacoast south, it's 200 feet by 200 feet, and Rye has the most resolution. Right near the coast, it's 50 feet by 50 feet. And you'll notice on the Coastal Viewer, the Rye results load the slowest because there's a lot of detail there. Next. We also simulated saltwater intrusion, but we did not do saltwater intrusion for the whole area. The seacoast model to the south was done really early on. It was the first model that was completed, and we actually didn't create our own model. We used the USGS model, and that was not a saltwater intrusion model. So we only have saltwater intrusion for the coast of Rollinsford, Dover, Madbury, Durham, and then in the Newfields Exeter area and Portsmouth Newcastle, but we don't have it down south in Seabrook or Hampton, any of those areas. Next. So this will be an example of some of the simulations that you can see on the Coastal Viewer. Next one. This is groundwater rise. So what we did was we simulated sea level rise of 1 feet, 2, 4, 6, and 8 feet. And then we modeled to see what would happen to the groundwater as the sea level rises. So this, what you're seeing here is the groundwater rise. That means the level of the water table above a datum, which is NAVD 88. So the actual groundwater rise is relative to the groundwater level. It means sea level. So with 1 foot of sea level rise, the blue is showing a little less than a foot groundwater rise. And with 1 foot of sea level rise, we see that we hover around 1 foot or less in terms of groundwater rise near the coast. Next. This is with 2 feet of sea level rise. The next one is 4 feet. Go to the next. And the next one is 6. And the next one is 8. So these maps are showing us the projected magnitude of groundwater rise with these levels of sea level rise. And you can see that the red is the highest, the highest predicted groundwater rise. But the point that I really want you to get out of this talk is that even though we're simulating groundwater rise, it doesn't necessarily mean that there would be impacts from that groundwater rise. It really depends on how shallow the groundwater is in the first place. And there'll be more on that next. Next slide. So the next piece of this is really the groundwater depth. So we also simulated the depth to the water table, meaning the distance between the ground surface and the top of the groundwater table. And we mapped out groundwater depth zones. So what we're seeing here in green is where groundwater depth is projected, not projected, but predicted by the model to be less than 15 feet deep. The next one, please, is groundwater depth less than 10 feet, and the last is groundwater depth less than 5 feet. Now, these groundwater depth maps are with no sea level rise. So these are, this is giving you these depth zones as they are today. And we're using these depth zones with the groundwater rise information to find the areas that are vulnerable. And when we talk about areas that are vulnerable, when you have rising groundwater, or when you have shallow groundwater, it can impact basements, it can impact infrastructure, underground infrastructure like sewer pipes. It can also impact roads, coastal roads. So now the next slides will show how we've combined these areas of shallow groundwater with the groundwater rise. So we're calling these the vulnerable areas. This is vulnerable areas where groundwater depth currently is less than 10 feet, and we're showing the groundwater rise in those areas. Next. So again, same thing. This is with 1 feet of sea level rise. But if you notice, there's not as many areas that are affected when you compare it to the groundwater rise maps, because again, we're only looking at the areas where the groundwater is less than 10 feet deep to begin with. So up in Dover and Madbury and Durham, you don't see as much impact. You do see some impact along Rye, where we've got a lot of wetlands, and in Newfields and Exeter area. Next one. This is 2 feet. Next. 3 feet, 4 feet, I'm sorry. Next is 6 feet. And the final one is 8 feet of sea level rise. And what's great about the coastal viewer is that you can either look at the map like we're seeing it now, although it takes a long time for it to draw all of it, or you can zoom into your area of interest. So next slide, please. So this is, I'm going to show you a few maps where we're zoomed into the community scale. Next one. This is still the vulnerable areas where the groundwater depth is less than 10 feet. But this is with groundwater rise of 8 feet of sea level rise, with 8 feet of sea level rise. And this is in Dover and Madbury, Durham, and Rollinsford. And you can see, I don't know if you remember, but when we looked at the groundwater rise map, the area in Dover, a lot of the area in Dover was all red. And now we're showing that there's a smaller amount of vulnerable areas, and that's because the groundwater depth was deep in those areas where you're expecting a lot of groundwater rise. Same with Durham. Most of the impacts are right around the river there. Next. This is a little further south in Newfields and Exeter and Stratham. So same thing, we're looking at groundwater depth of less than 10 feet with groundwater rise of 8 feet. Next, please. This is the Portsmouth, Ryan, Newington area. Again, these are areas where groundwater depth is currently less than 10 feet with 8 feet of sea level rise. And again, with the coastal viewer, you can zoom in even closer. Next. And then this is the seacoast. This was done with the original model. So we're showing the coast there. Same thing. Next. And we did the same with the groundwater depth zones of less than 5 feet, which are really important for roads. Because when groundwater is less than 5 feet, or in the 3-foot area, it can weaken the pavements. And it's also important for shallow infrastructure. Less than 10 feet would incorporate, deep sewer lines, but less than 5 feet will incorporate most of the shallow infrastructure. Next. So these are the same maps. We can go through these quickly, but you can see that the vulnerable areas are less because, again, this is limited by the zone where groundwater depth is less than 5 feet. Next. And then we took a look at saltwater intrusion. So for saltwater intrusion actually moves further inland the deeper you go. So we first looked at the overburden, which is the unconsolidated sediments above the bedrock. We looked at 2 different scenarios. Well, we looked at all of them actually, but this is what we're presenting. We're presenting the situation with no sea level rise and with 8 feet of sea level rise, which is the current condition, and then of course the worst case. And then the next ones will be in the bedrock, and you'll see that the predicted saltwater intrusion is further inland in the bedrock just because it's deeper. Saltwater is more dense than freshwater, and so the deeper you go, the further inland that saltwater wedge moves. And that's important because there are a lot of very deep wells in coastal New Hampshire. So the deep wells would be affected by saltwater intrusion more than the shallow wells would be. Next. And you can see saltwater intrusion is predicted right along the coast in many areas here. This is in the overburden, and on the coastal viewer, the colors that you see is relative salinity, which is really freshwater is considered 0, and saltwater is considered 1. So when you see the light blue, it's 0.1 to 0.2, and then the red color would be 0.8 to 1, which would be saltwater. And this is with no sea level rise. So the next one will be with 8 feet of sea level rise. So you can toggle back and forth between these two and see the difference. It doesn't really move a whole lot further inland, but you see more salinity right at the coast. And then the next one, we'll take a look at the bedrock. And you can see that deep in bedrock, the inland extent of the saltwater intrusion is greater than in the overburden. And so this is with no sea level rise, and the next one is with 8 feet of sea level rise. So you can toggle back and forth. You can see there's not a huge effect of sea level rise, doesn't have a huge effect on the inland extent of saltwater intrusion. What's really important is well pumping. Wells that are deep and close to the coast can draw saltwater in. So next slide, and this is the last slide. This is just showing the same thing in Newmarket and Newfields for no sea level rise in bedrock. And the next slide will be with 8 feet of sea level rise in bedrock. And we've overlaid the active public water supply wells here just to show you which ones might be impacted. Most of them are not, but there are a few that are in the area where saltwater intrusion might have an impact. And that's it for me. Next slide. If you need more information, feel free to contact me. And again, I'd like to make the point that these models are for a much larger area than just along the coast. So it's important if you have questions that you need to have answered with water supply or water quality or drought or other impacts of climate change, you know, take a look at these models before you spend all the money to build another one. All right, thank you.
Thanks, Jane. One quick question, then I'll present and we'll do other Q&As. How long has that been on the Coastal Viewer? Was that published in the last month or two, right?
Yeah, just by the end of the year.
Okay, great. All right, so we're moving to our last speaker for the hour, which is myself. I'll be presenting on a couple data sets, the New Hampshire Shoreline Structure Inventory, as well as kind of highlighting the coastal flood risk model that is to come. I have to say next, but there we go. Okay, so we presented on this some other locations, but it's great to get the word out there. We recently updated our New Hampshire Shoreline Structure Inventory. It is on the Coastal Viewer as of, I think, early December 2025. And this is, again, an update of an older layer that was published in 2016. Before diving in, just want to acknowledge our funding source is PrEP, but also really who did the weight of the work for this update. This geospatial layer was really developed by our coastal program intern from the past summer, Chris Bucher. He, reviewed the original 2016 data layer. He did a lot of actually all the field verification for this new layer, also reviewed and scanned DES permits. So this is really his project. These are also mostly his slides. So big kudos to Chris for doing a great job and definitely going above and beyond what, Coastal Program intern does. Really appreciate it. So we'll dive into it now. So what we're talking about with the structure inventory, if folks haven't, visited or looked at this on the Coastal Viewer, it's really to map out geospatially where all of our engineered structures are within our, coastal zone, not just our 13 miles along the Atlantic coast, but also thinking up in Great Bay and our upper tidal rivers. The features that we're specifically talking about are kind of earthen berms. You can think of these along 1A, stretching most of, Northampton and Rye. Our jetties and groins that often are perpendicular from our beaches, kind of disrupting or reducing wave energy. Riprap and revetment, often, sloping down from properties with some smaller rocks and boulders, as well as seawalls, which are more, vertically aligned, larger boulders, again, protecting those upland infrastructure and assets. So these were the four features we had in our 2016 layer. For this 2025 update, we also included one more feature, which are living shorelines, photo taken from Wagon Hill. While these are more nature-based solutions, often in New Hampshire, we see kind of hybrid approaches, including, a rock sill, and it's still categorized as, some sort of shoreline stabilization protection. So we figured we'd include it, as well as, this is really our one way of tracking living shorelines throughout New Hampshire. I've touched upon it a little bit, but, what was the 2016 layer? There's a report associated with it. The 2016 layer used to be on the Coastal Viewer. It's now been replaced, but you're still able to find the 2016 layer through the geodata portal if you're interested. But prior to 2016, we knew all these engineered structures were out there on the coast. We didn't have a comprehensive map indicating where they were, or even knowledge of, how many miles of structure we had. So in 2016, Coastal Program staff went out primarily through aerial imagery, as well as, going out in the field, seeing what's out there to identify and create maps of these features. And really it was to inform, shoreline management decisions, kind of, again, identifying, how many miles do we have that are engineered versus how many are still natural? Are there areas where we could be emphasizing more nature-based solutions versus more hardened structures? So it's really getting that baseline inventory versus what's new with our 2025. We went back to look for those features, but there's also some more interesting things we're curious about. In 2025, it's not only been nearly 10 years since we've done this, but there have been some other changes we're curious to learn about. One being in 2019, DES revised Chapter 600 rules, our tidal waters rules, specifically related to shoreline stabilization. Some of that language associated with really promoting or emphasizing nature-based solutions where possible prior to installing something that's more of a hardened or armored structure like a seawall. So we're really curious to see, since those rules and regulations have been in place, has, the face of our shoreline structures changed in New Hampshire? So we're including living shorelines in this, as well as, we wanted to kind of carry out additional data. So we also included wetland permits. When any of these structures are, created off, they should be going through a permit process. Those are publicly available. It makes, reviewing and finding these new structures a lot more easier than going out in the field or looking at maps to see if there's a new structure. Instead, we can just refer to these permits to see, oh, yeah, there is a new structure in place as of 2022 in Newcastle. Additionally, there's a lot of information that comes from that in terms of, what was proposed in terms of the length and the width, and we can capture that in our attribute table for the new layer. So just navigating to where this is on the Coastal Viewer, it's beneath Oceans and Coasts, titled 2025 Shoreline Structure Inventory. Again, we have those 5 features of wall, riprap, berm, living shoreline, and jetty and groin. This is just showing a photo of Hampton Seabrook Estuary. Just want to go through some data. Again, this is really more to just emphasize, hey, this layer's out here. But with the data, there's some interesting, trends or patterns that we're able to explore and, encourage other folks to look into this data. Right now in this table, we're looking at just the data from the 2016 layer. Main things to pull out here is that the total was about 51.9 miles of armoring. So all those features across our shorelines. Our top communities with the most amount of armoring are Rye, where is it? Portsmouth, and Hampton. In our 2025 update, now we have the new totals. We do see some percent changes across some communities, but most of the communities haven't really changed. In total, we've gone from 51.9 miles to 52.6, so increase about 1%. And those three communities I mentioned in 2016 having the most armoring, those still are the most armored. Where we've seen the greatest change has actually been, minus Newcastle, has been Dover, Durham, Newington, Newmarket. So kind of further up in our coastal zone rather than along the Atlantic coast. Thinking about it again regionally, this isn't part of the Coastal Viewer, but just how we were considering, organizing it. We're seeing that the majority of our armoring is along the Atlantic coast. That's that orange line. Makes sense. That's where we have the most wave energy, followed by Portsmouth Harbor, Scotticoa River. And then to a smaller extent, we see the Atlantic coast embayments in the dark blue, Great Bay in green, and then the upper tidal rivers in purple. Again, just kind of noting some analyses that we explored. Since we had, the DES wetland permits, not only do those show new structures, they also note if they're maintenance or repairs. So we're really curious to see if there are regions of the seacoast that have more frequent or higher density of repairs. Maybe not surprising, it was a lot of our coastal Atlantic coast communities, Hampton, Newcastle, and Rye. This is again looking from 2016 to 2025. Any structures that existed, are there any maintenance or repairs? We're seeing those three communities as having, quite a large number of permits compared to our other communities. And specifically, what kind of structures are being repaired? It's most often riprap or seawalls. Also interesting just because we have the permits, we have, the years those were submitted and approved. This is just looking at, again, maintenance and repair permits by year and the number of permits. It's pretty small from 2017 till about 2022. And then we see this large increase in 23 into 24. The Wetlands Bureau was pretty busy looking through these permits. Primary reasons being is post-COVID, as well as 23, 24, we had a lot of coastal storms, maybe not huge wave energy, but also just tied with large precipitation events, plus high tides, plus strong winds led to a lot of, needing to repair these systems. Just because I'm not on the Coastal Viewer, just wanted to take a few seconds to just kind of drive around the coastal zone, just so you can sort of see what this looks like. Again, Atlantic coast, pretty heavily armored. Great Bay, not so much. The table just shows kind of the overall armored miles depicted in the image. Scotticoa River, Portsmouth Harbor, again, historically has been armored for quite some time. And then we also have photos of the upper tidal rivers, Cachiko River in Dover, the Bellamy River, Oyster River in Durham, Lamprey, Squamscott. Okay. And I'll shift over for just a few minutes to talk about the flood risk model. So spoiler alert, it is not on the Coastal Viewer at the moment. We are really any day now hoping to put some data onto the Coastal Viewer. But just want to give a quick kind of download of what to expect. So on the Coastal Viewer at the moment, we do have sea level rise scenarios layer, which has a lot of, 2-foot sea level rise, 4-foot sea level rise. These are what we call bathtub models, where you're adding just 2 feet to the existing mean water, and then just kind of showing a polygon of where that would extend to if it was 2 feet higher. These models are great for getting an idea of where water could be going, but it doesn't really track how water behaves. For example, once it's going over pervious surface or impervious surfaces like roads, it doesn't really accurately depict how water moves over roads. Doesn't really depict, water moving at different depths is different than if it's all at the same level. So again, it gives you an idea, but it's not the most accurate thing out there. Hydrodynamic model, which we're hoping to have online soon with the coastal flood risk model, includes more processes and data to more accurately depict how water is moving. Some of these include, waves, storm surge, as well as it's calibrated with historic storms. So for us, we're using winter of 78, as well as some more recent storms like Hurricane Sandy. Was that December 22, where we had that really large rain event with high tides. Again, using those to have an idea of where water is moving during those type of storms. The photo here is just showing a Massachusetts version of the model, just to have a comparison. There's going to be a lot of data that comes with the flood risk model. But what we're putting on the coastal viewer will be just what we call the annual exceedance probabilities, which I'll show a draft version in the next slide. These are more or less the likelihoods of flooding in a given area, and we will have these across different climate scenarios or sea level rise scenarios. So we'll have present day, roughly 2040, roughly 2056, 2083, and 2100. So you'll be able to click across these on the coastal viewer. And this is just an example of, Hampton Beach. Again, this is preliminary. This isn't the finalized version. And so just kind of quickly going through it again, this is showing likelihood of flooding. And the coastal viewer will also have this kind of color ramp. For now, just, darker colors mean it's more likely to be flooded in a given year. So our marsh, which gets flooded every day, is 100%. As you're going up in brighter colors, the chance of that area being flooded is less likely. So just want to give you a sneak peek of what it's going to look like at some point. I will acknowledge that we are going to have some trainings on this type of data, but just giving a sneak peek for now. So what's upcoming, those annual exceedance probability layers for all the sea level rise scenarios will be on the coastal viewer soon. But there's also going to be a bunch of other data that will be released and on Woods Hole's website. That includes wave heights, water surface elevation, tidal benchmarks. Those are going to be available on Woods Hole, but not the coastal viewer, just because it's more, I'd say, site specific. If you're, engineering something or designing it, that's the data you would be looking at. Additionally, we're going to have fact sheets and frequently asked questions. Those will be on the coastal program website, as well as a technical report that really gives, under the hood of what's going on in the model. Also, while this is going on, we'll have some case studies of areas throughout the seacoast using the model to identify, vulnerability assessments of 5 sites, as well as developing alternative analysis using the model to show, if you designed a road slightly higher, how does that affect, flooding and your resiliency? No, that was a huge thing to just kind of throw at you, but yeah, we're excited. There's a bunch of new data on the coastal viewer, and more to definitely come. So at that point, we'll just kind of throw it over to the participants if there's any questions. Maybe Becca, you've been scanning the chat.
Yeah, thank you to all our presenters. That was so interesting. I knew some of it, but not all of it, so thank you. So it looks like we have a question in the chat that is about armoring. So do you differentiate between historical thinking like 1800 to 1900-ish versus recent other than in attributes? I think that's directed towards you, Aiden, but I'm not sure.
Is that, or no, Peter, maybe you could expand on that, differentiate. When we're mapping it, it's just anywhere where we are seeing walls of any sort, we'll include it in this, whether or not it's a newer one or an older one, but maybe I'm not understanding totally.
Yeah, that was my question, was whether or not happen to live on the Oyster River in Durham, and we have some really, really old armoring down on our shoreline that probably was related to a brick factory that was here way back in the past that has anchored the shoreline. We have some marsh that's encroaching, so it's kind of like a living shoreline setup at this point. I didn't know if you guys were, how you are handling that sort of thing, whether you even know about it, if you are really relying on modern versus, let's call it colonial era stuff.
Sure. Yeah, that's interesting. I know for the original layer, for field verification, coastal program staff was going out on boats to really check all these rivers. I don't think we had the opportunity to do that for this update. So, if you have a chance to review the layer, maybe just let me know if we captured it or not. And if not, would be curious to look at it further.
I'm not seeing any other questions in the Q&A or the chat. Oh, I see a hand raised. Perfect. Go right ahead.
Hello, getting off my mic. Yeah, Tom Retberg here from the Newfields Conservation Commission. The content by all three speakers is great. Thank you. And myself and probably one or two others in the commission will be using this tool. So really appreciate it. I've got at the start a super simple question. That is, what URL is best for the public? Because there's a coastalviewer.org and there's a UNH portal that seems to need a login, and the DES seems to have a way in. Like, what's the most quickest to load, I guess would be the question.
Well, you can go to get to the Coastal Viewer, you can go straight there with nhcoastalviewer.unh.edu. The nhcoastalviewer.org has a kind of portal associated with it. So there's lots of training information. That's where this will be. So it's not a login to get to it. It's just an extra click to launch the viewer itself. But yeah, those would be the two ways to get to the Coastal Viewer. Yeah, and Becca's put a
so
link
one you have to log
to
in, one you don't. Okay, it's the same thing. Okay.
It shouldn't require any credentials. There's just an extra click from the coastalviewer.org because you have a page with additional information when you first get there.
Okay, thank you. Are there any layers that don't have data with them? So you might click on the layer and then nothing loads, it might indicate a layer, but nothing loads and you're kind of wondering if it's got something or not.
There shouldn't be any that are empty, but
okay,
some can be slower than others.
Sometimes with these map things, you get that and you're kind of not unclear whether it's not loading or there's no data. Thank you very much. And a question for Jay. What is the general bedrock? You mentioned the bedrock under this area around Great Bay. In a few words, what is the bedrock we're dealing with for the area?
So a lot of granite. It's fractured bedrock. It's fractured near the surface. It gets more tight, or not as many fractures as you go deeper. But there are fracture zones all the way down. So we do have a lot of public water supplies in coastal New Hampshire that are in bedrock in these fracture zones, and we're able to get some water out of them. As far as the actual geology, it varies, and you can get the geologic maps, the bedrock geologic maps, off the New Hampshire granite information. So if you want to look in your specific area at what exactly the bedrock is, you can get it off of that.
Right. Yeah. Okay. Thank you. Just wanted a little intro on that. Appreciate it. Again,
Yeah,
great
no
tool.
problem.
Awesome. Are there other questions?
I just wanted to follow up on a couple of those questions. I do get also the pop-up that you have to sign in sometimes when you're on the Coastal Viewer. But you need to, usually I can just hit cancel and get out of that and then able to use the Coastal Viewer. And also sometimes with layers, if you're not seeing it, you just have to remember you have to click on the upper layers too in order to see it. Sometimes you don't think about that when you're clicking a layer that, oh, there's a couple other layers above it that you need to click to see it. So just wanted to add that to it.
Thanks, Jen. I see Emily's hand first, and then we'll go over to you, Jane.
Oh, that was not an accident. Thank you.
Oh, okay, thanks. All right, Jane, you're up then.
Yeah, I just wanted to mention that when looking at the groundwater layers, first of all, I mentioned in the chat that you can find the groundwater layers under the oceans tab, which isn't necessarily intuitive, but because it's sea level rise, it's in that. And then when I've taken a look at it, it takes quite a while to load. And if you're finding that it's not loading, just zoom in to the area of interest and it will load. And when you zoom out, it kind of goes away. So it's probably best to zoom in and you'll find that it does load more quickly.
Thank you. Any other questions before we wrap up? All right. So our next webinar will be, drum roll, April 9th at 10 a.m. And this webinar will be on our Caring for Our Marshes online guide, which New Hampshire Coastal Program partnered with the National Great Bay Estuarine Research Reserve. So we are very much looking forward to that. We hope that you all will be able to attend, and that link will be live to register very soon. So thank you again to all of our presenters and for all of our attendees for our first Making Waves webinar.
Thank you, everybody.
Thank you.